Hello class, let's start our lecture 33. We talk about regression inference. That will be the last regression lecture we have from this series. So we know from the last week, we start talking about the regression. So then we have the correlation between two numeric attributes. So then we can find the regression line. So to see the regression line is a good fit or not, we need to examine our residual. So that's why the previous lecture we talked about residuals. So residual basically is try to analyze any mistake or error we have from our regression line. So once we make sure our regression line is good, then let's talk about the regression inference. So after today's lecture, the next lecture we will talk about data and privacy. Then the next module we will talk about the classification. So the module 14 we will give you 2 case studies. So yeah, that will be all for our semester. But let's finish our regression. In this lecture we will first talk about regression model. Then we will introduce the prediction interval. Then we talk about the true slope. The first one, let's talk about the regression models. Like earlier, we talked about in the past lecture and the previous lecture. After we observe our residual from our regression line, we examine, right? So the mean of the residual need to be 0. And residual has no correlation with the x, no correlation with the fitted value. Then we're confident that a line is a good fit for our data set. Right, so we have our sample data. We think this line is a good fit. The linear line is a good fit for our data set. But how can we make sure this regression line from the data set we get is also fit with the population? Yeah, remember our population, different people get different data sets. Okay, so maybe different data set, we have different regression line. So that's we talk about the concept about the inference. So the inference is as long as we are trying to estimate, so what is the variance about our estimation? So that's we want to talk about in this regression model. So our model, we try to get the model is among 2 numeric data attributes. So whenever we have a model, we always have the noise among that model. Then we need to do the justification. So like earlier we say, this regression model is we already assume you check everything. We know the linear line is the best fit for our sample data set. So then let's talk about further. Okay. So in this regression model, the first thing, since we believe the true there's a line to best fit in our data set, so we just think about we do have a true line here. So this true line, what is the slope? What is the intercept? That's what we want to looking for. But so far we didn't know. From this true line, actually for all the data set we see, they came from the population. They came from random. So on the other hand, even we have a true line to fit in all those data, but those data, they have some noise in between. So that's why we say here, we make a one data here. So this data, we have specific x. So then we have the y here. The y, the observed y between the estimate y is the distance we draw at random from normal distribution with mean 0. On the other hand, we do know we have a true line. But those true line, all the data we make of, they are not always all the data just on this true line. So we just know from the population, our population distribution was similar to like the normal distribution. They have the mean equal to 0. So the distance drawn at random from the normal distribution mean, that's why we have 1, 2, 3, 4 different distance drawn independent from the same normal distribution. So that's you see here. But that's you already think we have a true line. is the data set we see before we try to analyze our data. That's what we see, right? We collect our sample data. We make the scatter plot. So that's our data look like. So then we try to have a regression line to see how the regression line will be. So then in our demo file, we want to show you, we will simulate, we just have our scatter plot. Okay, so then we do have a true line. Based on this true line, we have our sample data set. And from that sample data set, we try to find our regression line. So then we want to see how our regression line close or meet our true line. So let's see how from our demo file. Of course, we still have those functions we need for our regression. So then we talk about the regression model. So here you don't need to really know how those code working, but this code just a graphics try to demonstrating the regression model. So like earlier we say, if we have a true line, we know the slope, or we don't know the slope, but they do have a slope and intercept, right? So according to different size of data set, that's how we define a draw and compare function. So in this compare function, just according to the slope and the intercept you provide for this true line. So then we random generate the sample size you specify. So how to generate those points? Of course, like earlier we say, the model we do have those noise for the data, the distance between the data with our true line. So, but they will be close to the normal distribution. They have the mean equal to 0. So that's how we will have those XY coordinates to create. So that's why here we just see, for example, we just say this true line we have, you have slope equal to 2 and intercept equal to -5. If we only have our sample size is 10. So on the other hand, that means we generate just 10 points. Okay, so here is our true line. Okay, so then we just random generate the 10 point. Okay, so at this 10 point, like we say, the true line is, we assume we have a true line, but as a data analysis, we cannot see that. What we see is we just go to have a random sample, then that's our sample data. So then go through our sample data, of course, we can find a regression line. Okay, so that's why this regression line is according to the data we have. Then we calculate standard deviation and correlation. Then we got our, so this, the dark blue is our regression line. So then let's put this regression line together with our true line. Yeah, we'll see they kind of close by. But you can see the slope looks similar, but they do have some differences for the intercept. Okay, so continue the same thing. We can run again. We're still using the same true line. We still create 10 points. But in this one, you can see here, of course, the first one is the true line with the scatter plot you have. But for us, we only see those data like this. Okay, so you can see this one, they have more far away 2 points. But of course, that's what we get for our sample data set, right? So then we can get our regression line. Okay, so when we have our regression line, we calculate according to the correlation. Then that's compared with this regression line with our true line. So this one you can see, yeah, they are close by. Yeah, they are close to each other. Okay, so this one you can see they are slope maybe close, the intercept is close, but we still need to adjust a little bit for the slope. Okay, so that's the sample data size is 10. How about we change to 100? Okay, so of course we change to 100, we will have 100 data set scatter plot we create. Okay, so you can see, of course, they look like it's more, not so much outlier. That's because we have more data. Okay, so of course from here we can draw our regression line. So then compare the regression line with our true line. Yeah, so you can see, yeah, it's close. So just like our second one, they cross each other, but you can see the distance in between is smaller than our size 10. Yeah, so for size 100, that's what we get for the first time. But like we say, sample data set, we can draw from the population. So that's why different people get different sample data set. So that we can run again. Okay, so then we have another sample size is 100. Then we get our regression line. So let's compare this regression line with our true line. That's even more close, right? Okay, so what we can see here from our simulation, we find out if the sample size is big enough, then we find out this regression line we estimate is more close to our true line. So that will be very similar as earlier we have from the before the lecture we have. If we try to have our sample size is larger, they are more close to the population. So from here, we can see the sample size actually will help us to have our regression line better fit to the true line. So after we talk about the regression model, okay, so the regression line, even we talk about regression model, we think the population will have a best fit using the straight line to represent that. But we do have our sample data set from different drawing or different random set. So we get, so you and your classmate both get sample data set from one population. But according to the data set you both get, your regression line maybe have slightly different. Okay, so that's a prediction variability. We're using the regression line to get estimation. We try to do some prediction for the given X. However, from different data set, they may have a variation from our prediction. So that's the next one we want to talk about, the regression prediction. So the regression prediction is if the data come from the regression model, we do have a true value of the response y at given value of x is the height of the true line of x. Now remember, like earlier we said, we do have a true line there. We do have a true value, this value y on the true line corresponding to the x we provide. So this response y is what we try to estimate. Since we don't know what the true line is, what we can do is we just have our sample data. We find the regression line. Then we use the regression line to estimate the height. So the regression line is most likely close to the true line. Yeah, like earlier we showed you the regression model according to different sample data sets. If you have bigger sample data size, they may have the regression line close to the true line. So after we know that the regression line will be close to our true line, so then we can have the value x to predict y by finding the point on the regression line at x. So that's our example. In our prediction section, we want to go back to our baby file. Also remember, we do have a baby file before. We have the mom's age, mom's height, and also we have the pregnancy date. So that's using the pregnancy date this time and the birth weight. We try to have our scatter plot. Okay, so from this scatter plot, let's see here. So we do have a lot of outlier. Okay, so few outlier if the pregnancy time is not enough, or they have much longer time. Okay, so this one actually is what we try to get a little less noise from our sample data to find our regression line. So that's why earlier they have it's like between 37 to 42 weeks. But here let's try to get our birth only between 225 days to 325 days. So then we see our scatter plot again. Okay, so compared to the other one, this one is much better for that.